So let me just give you a quick summary of the stuff what we have seen in the previous class. We have just seen what stacks are, right? So stack is a structure which allows the user to just put data only in the last position, and the data that could be retrieved can be only from the position where we have just lastly added elements. So it is working with a concept called as last in first out. So we call that in short as LIFO, right? So LIFO is the method in which the stacks will operate, right? So where actually this kind of structure is really needed is during function calls, right? And in the case of undo operations. So in the case of undo operations, like when you just type something in Word document and you just press undo, what will happen? The last operation that was done will be removed, right? It does not say if I just type A, B, C and if I do undo, only C will get removed, right? The last action will get undone, right? For other things like that, this is where actually the stack structure is being used. So the system is going to keep track of all the actions that you do in the stack structure, right? So whatever you do first will go to the bottom position, whatever you do last will be on the top. So when you just press an undo key, the last action that took place will be like it will be undone, so it will be removed, right? So that is how this undo operation works, like where again we make use of the stack structure, right? So now let's see the other applications where the stack structure is of great use in computing system. So we'll be looking into conversion of infix expression into postfix. I'll tell you what this infix means. Postfix and prefix, and evaluation of expression. So these are the two major cases where the stacks find its application. Let me help you understand what infix expression is and how the stacks is going to help us to convert this infix to postfix or prefix, and why it is really necessary to convert an infix expression to postfix and prefix in computing system. So you would have worked with a lot of expressions, right? Say like arithmetic expression, for example, say A plus B star C minus D. So given an arithmetic expression like this, so how do you go for evaluating an expression? We work with a lot of other kind of expressions also, logical expressions and string expressions, anything, whatever it may be. You have in all the expressions, you have some set of operands and operators, right? So this combination of operands and operators is going to get you an expression created. So this expression maybe, see here you're going to have precedence attached with every operator that you have in the expression. So if you have an expression like this, which I call as infix expression, why? Because the operator comes in between the operands. The expression is called as infix when operator comes in between operands. So operands are nothing but the variables on which this operator will be applied on. Okay, so if I say A plus B, then this plus is an operator which is going to be applied on the operands A and B. So I call this plus as a binary operator because it needs two operands. I hope you are following me. Is this clear? All these things I think you'd have already done. These are basic math, what I am repeating here just to refresh you. So infix expression is an expression which is going to have operands and operators, wherein operators are going to come in between the operands, right? So every operator what we have has its own precedence or the priority attached. So if you are given an expression like this and say for example I assign some values to A, B, C and D. Let's assume that A, B, C and D assumes the value 1, 2, 3 and 4 in order, right? So A assuming 1, B assuming 2, right? So what is the answer? What is the result after evaluating this expression you get? You substitute the values. in place of A you're going to have 1, and in place of B you're going to have 2, then multiplication symbol, that is star, then 3 minus 4. So how will you evaluate this? Will the evaluation be done just simply blindly from left to right? Normally evaluation of the expression will happen only from left to right. Right? But what should be the answer for this? Will it be 3 into 3, 9, 9 minus 4, 5? Or 2 into 3, 6, 6 plus 1, 7, 7 minus 4, 3. Which answer is right? Which one is correct? Guys, how will you evaluate this expression? This is a very simple arithmetic expression wherein you have only plus and minus and this multiplication symbol. How this expression will get evaluated?
Ma'am, there are answers in the chat, ma'am. They're stating test 3, ma'am.
No, I could not see the chat box. Please unmute yourself and give the answer, because I am just sharing the entire screen. If I try to share a window, then I am not able to do it properly. My speaker is not working. So please do understand. If you got the answer, unmute yourself and give the answer.
I think the answer is at 3, ma'am.
Answer is 3.
Yes, ma'am.
How and why? How the answer will be 3?
Ma'am, the answer is because we are using Bodmas rule here, ma'am.
Use Bodmas rule, yeah. Then how do you apply that?
First we will multiply, then addition, and then subtraction, ma'am.
First you multiply, then you add, then you subtract. So that is how the Bodmas works. Like you assign priority to the operators, right? So you assign priority to the operators. We know to apply Bodmas, but how the system is going to work on this? Did you ever teach the system about Bodmas rule? But the system does it right for us every time, whatever be the complexity of the expression. So here again, this precedence could be overwritten by the user. So I could say 1 plus 2 into 3 minus 4, wherein this operator minus is going to have a precedence higher than the star, because it is coming inside this bracket. So what will be the answer for this expression? So whatever you have within the brackets will be evaluated first, right? So this 3 minus 4 will be evaluated and you get minus 1, and 2 into minus 1, then this part of the expression will be evaluated where you get minus 2. So 1 plus minus 2, the answer will be minus 2. See, the numbers, the values of these variables are the same, right? And the positions of the operators are the same in this expression too. But because of this brackets, what we have put between this 3 and 4, right, or within that is to cover this 3 minus 4, the entire result has got changed. So even for this expression, the system is going to get us the result very correctly. It is going to give us minus 1. But do we teach the system anywhere in the code, or do we write a function anywhere in the code to evaluate or to apply this Bodmas function to evaluate the expression? We don't do. It is already taught. So how it is going to be done? And the expression is going to be very, very complex. Even the simplest expression becomes complex for the system to evaluate when you have lot of brackets like this, because precedence of the operators are being overridden. See here, I can have then 3 minus 4. So wherein this plus and minus overrides the star. You have apply plus, then minus, and only then apply the star. right? So here, if this is the case, how actually the computer will evaluate an expression when it is given in infix form is, it will just start scanning. Scan from left to right. Always evaluation will happen from left to right, right? So that is how we normally work. So it will just start scanning. So you have 1 plus 2 star 3 minus 4. Let's assume that this is the expression what we give. So this is an infix expression, right? So yeah, when it starts scanning, it will just try to find out the brackets first and try to, that is, it is just try to find out the sub expressions, right? The expressions which come inside a bracket in the infix expression is called as sub expression. So all the sub expressions has to be evaluated first, right? So all the sub expression has to be evaluated first. So it will just try to find out all the sub expressions. So in the first scan, it will just try to identify this sub expression and it will evaluate. It will get the result as 3 and it will have it as 3, right? And then again it will try and completely trace the expression. So it finds the next sub expression. So it is going to apply the minus operator here and it will get the result for the sub expression. So it is going to be minus 1, right? And again it will just trace. So all the sub expressions has been evaluated. So this star has to be applied on these operands. So it will now apply the star and it will just get the result. And the entire expression has been evaluated. So this, see, even for the simplest expression, the system has to scan the expression for 3 or 4 times, right? It has to scan the expression at least 3 times or 4 times here in order to identify the delimiter. Again, it will check whether the complete expression has been evaluated or not by checking the delimiter. Delimiter is character that is going to mark the end of the expression, right? So as you have in the C program or C++, you just delimit every statement with semicolon, which marks the end of the statement. Similarly here, we use a hash symbol to delimit the end of the, to delimit the expression, or say mark the end of the expression, right? So for even the simplest expression, right, wherein you have got no more than 2 sub expressions, the system is going to scan the expression many number of times, right? So the number of times the expression has to be scanned to get evaluated and to get the result for us is going to be more when the complexity of the expression is very high, right? So the infix expression as such could not be evaluated in minimal time. So we just go for other kind of expression called as postfix and prefix. So why we go for using this postfix and prefixes? This postfix and prefix, both these forms of this expression, is not going to have any parentheses, no brackets, or parenthesis free expressions. So if there are no parentheses or no brackets like this, then in just a single scan, the entire expression, whatever be the length of the expression, whatever be the complexity of the expression, the entire expression could be evaluated in one single scan. So that's the reason why we go for using either postfix or prefix. So internally, even though you give expressions in infix form in your code what you write, internally the compiler is going to convert this infix expression into either postfix or prefix in the way it has been designed to do. I hope you understand and follow me. Purida?
Yes, ma'am.
Ma'am?
Yes?
Yes, ma'am. Yes, ma'am.
Okay. So here, this is the reason why the conversion of infix to postfix is really needed. I'll just show you how a postfix will look like for a simple expression. Say, if this is the expression, then this is infix. Obviously, you have the operator coming in between the operands, right? So the postfix form of the same expression will be AB plus, and the prefix form of this expression will be plus AB. So name itself helps you understand what actually the expression is all about. So expression is going to have the operators at the end of the operands. In the case of postfix, post operand, and in the case of prefix, the operator is going to appear before the operands, right? So here it is pre. It is appearing before the operands. So operands A, B are coming after this plus. And here when you just look into postfix, operand AB, then comes the operator. Operator taking the last position. So all with respect to the operator we talk. When the operator comes in the end, then it is postfix. When the operator comes before the operands, then it is prefix. When the operator comes in between the operands, then it is infix. Right? Now let me help you understand how a complex expression could be manually converted into prefix or postfix. So we have a specific method to convert it. Let's take some expression maybe. Let's take an expression. So let's take this expression, and this marks the end of the expression. So for manual working anyway we don't need this. Only if you're going to write code, then you need this delimiter, because your code has to understand where the expression ends. So now for the time being, let us not bother about this, right? So now let's see how this could be converted into a postfix expression, right? It is very easy. We have only 3 steps to go. First thing is, you have to fully parenthesize the expression. So how can you fully parenthesize the expression? Fully parenthesizing expression needs you to know the precedence or the priority of the operators. So here I use simple arithmetic operators for which we know the priorities. The highest prioritized operator here is this cap symbol, which is nothing but exponent, right? And next comes the star and slash, multiplication and division, and next is plus and minus. Both have the same priority. If you have 2 star 3/5, then either you can compute this 2 star 3 first, or you can do this 3/5. So the result is not going to change. So they have same priority, right? Both the star and slash have same priority, and this plus and minus has got a lower priority compared with these 2 operators. So supposing this has got priority 1, and this has got higher priority, and this priority of this exponent is 3. The higher the number, the higher the priority too, right? Let us think like that. So now you have to parenthesize the expression considering the priority of the operators. So I am just trying to help you understand the manual conversion of infix expression into postfix. சரி, அது போய் வாங்கிடலாம். So conversion of infix to postfix. You can apply the same technique to convert the infix expression to prefix also, with a very little change in the method what I teach you. So the first step is to fully parenthesize the expression. You can just make a note of the steps, so it will be easy for you to understand and apply this later. Fully parenthesize the expression, right? So how to fully parenthesize the expression? Just take the expression, scan the expression manually, and try to find the operators with higher precedence. So here cap symbol has got the highest precedence in the given expression, so I just parenthesize this part of the expression, and again scan. Star is the next higher priority operator, so just put a bracket over here. Then plus and minus, either you can do this first, but always we go from left to right, so we just parenthesize this part of the expression first, and then comes minus, parenthesize it. So this is step 1. Okay, so now step 2 is map all the operators towards immediate closing brackets. Step 2 is map all operators towards immediate closing parenthesis. right? So here let me just do it for you. So here you always start from the innermost sub expression, so that will be easy for you to do. So taking the innermost, you will not go wrong in that case. So innermost is start 5 and here it is 2 cap 3. So here taking this operator, the immediate closing bracket is this, right? Just do the mapping and coming here to star, the immediate closing bracket is this bracket which is appearing after 5, right? And coming to this part of the sub expression which is between this one and here, right? So you have another operator left and the immediate closing bracket for this plus will be this one. And similarly here you have minus comes between the first opening bracket and the last closing bracket, so this would be the immediate closing bracket for minus, right? So we are done with step 2 and now let's see what has to be done to get the result. So it is very easy, just drop all opening brackets, right? So rewrite the expression. Replacing closing brackets with the mapped operators. I'll show it to you now. See here, the first step is to just scan the expression and fully parenthesize the expression. Fully parenthesizing the expression is nothing but scanning and find outing the precedence or the priority of the operators and putting brackets over there, right? Forming sub expressions, right? So once it is done, so fully parenthesizing is like having this opening and closing bracket which encloses the entire expression, right? So that is what we call as fully parenthesizing, right? So once it is done, the next step is to map all the operators with its immediate closing brackets. So that is what has been done in the step 2 here. Now step 3 is to rewrite the expression leaving all the opening brackets and just replacing the closing brackets with its mapped operators. So what I do here is I just start reading from the LHS of the expression. It is opening bracket, so drop it. Next is also opening bracket, so you're going to drop it. And next is an operand. So operand has to be taken in the resultant expression. So I just write the operand here, write down the operand in the result. And now next is plus. Plus is not going to be here anymore. Instead it is going to take the place of this particular bracket to which it has been mapped. So I'm not going to write plus here. And so I just move and I read the next character. Next character what I read is the opening bracket, so you simply drop it. All the opening brackets has to be dropped. So we just drop the opening bracket and go to the next character. Go read the next character. Next character what I read is an operand, so I just write the operand over here. And what I read next, it is star. So if I'm reading an operator, then the operator is going to go to some other new place, so I'm not going to copy it down here. So I move on here in the expression, input expression, and read the next one. Next character what I read is 5, so I just write it down, which is an operand, right? So operands has to be simply taken in the resultant expression, so I just write it down. And next is what? Next is a closing bracket. Closing bracket has to be replaced with what? It's mapped operator. So I'm just going to replace this closing bracket with the operator that has been mapped to it, that is star, right? And next is again a closing bracket. So this closing bracket is going to be replaced with plus. And now minus is the operator which is going to go to a new place, so just don't do anything here. Read the next character. Next character what I read is opening bracket, so draw. And next is a operand, so write it down in the resultant expression. And next is an operator will take a new place, so don't bother now. And next is an operand, write it down. And it is a closing bracket. If it is a closing bracket, then you have to take the operator that has been mapped to this particular bracket, closing bracket. So that is par symbol here, so I just note it down. And next is closing bracket. That closing bracket has to be mapped with, it has been mapped with minus, so I just take minus here. So this marks the end of the expression. So next character what you read will be a hash symbol here, so which marks the end of the expression, so I stop. Now this is the postfix form of the given expression E. So here, how this, say you can just try this for some simple expression. So A plus B minus C. A plus B both have same priority, so I can just put brackets like this. So the immediate closing bracket to this plus will be the closing bracket coming next to B, and for this minus will be closing bracket coming next to C. So expression now will become AB plus C minus. Right? So let us see how this is going to work exactly, the way in which we evaluate the expression where it is in the infix form and get the result. Let us check whether we are getting the right results. Right? So for example, if you just take 1, 2, 3 in A, B and C, the result is going to be 3 minus 3, 0. Right? So here again it is 1, 2, 3. How this expression be evaluated as, the system will start scanning from the LHS as it does in the normal case, right? So we just start reading the expression from left hand side, and if we read an operand, we don't do anything. If we read an operator, then we just try to identify whether that operator is a binary operator or unary operator or an operator which needs, I think it is tertiary, I don't know the spelling correctly, maybe I may be wrong here. So there are operators which needs the three operands. You would have just used this if statement in the shortest form, which actually needs 3 operands in C. Have you ever tried? You have if condition, and if the condition is true, you will do something, and if the condition is false, you will do something. So this if statement has been converted into an operator there in C, and which takes 3 operands, one operand for condition, another operand for true case, another operand for false case, right? So those are the cases where you have an operator which needs 3 operands. So you have to look for the type of the operator here. So if it is unary operator is nothing but like not symbol, negation, all these are unary operators which takes only one operand. So if I say minus A, then I am just negating A. If A takes value 3, the result of minus A will be minus 3. Right? So negations, this not is for logical. If I say not of something, say not A. If A is true, then the result will be false. Right? So we have different kinds of operators. So you have to look for the type of the operator. So if the type of the operator is binary, then you take the preceding 2 operands and apply that operator. So I am just helping you understand how this postfix expression will be evaluated. Be able to follow me? Yes or no?
Yes, ma'am.
Okay. So here, what the system will do is, it will just start reading from the left hand side, and once it encounters an operator, it will immediately take the preceding 2 operands. So this plus is a binary operator, we all know. So it is going to take preceding 2 operands and apply this. So A plus B will be done, and the result will be again put back in the expression. Now you have 3 and minus, right? So now it will again start reading from LHS, and or it can start from here because this part is already done. It can start from here and now read, and it stops here because it reads an operator, and this operator is minus, so it is going to take the preceding 2 operands and it applies this on these 2 operands. 3 minus 3, it is 0. So you get the answer right. So even if you evaluate the expression in infix form, you get the same answer 0, and in postfix form I get the same answer 0. So evaluation is good. The system here, one thing what you have to understand or keenly note at this point is, like, the system is not going to worry about the precedence. The system need not worry about these sub expressions. System need not worry about these brackets because the entire expression is bracket free. You could see, right? So even if the expression has been, the operator's precedence had been overridden, you can get this bracket free expression in the right form. We can, let us try another example for that. You just get me some example. Let us try some example. You just get me some expression. some complex expression. Let us try. There are more than 100 in the class, not even one single soul can get me expression here. Just an example expression, I'm not asking you any answer for the question. This is not a question at all. It is just a request, just get me an expression. Saif, get me an expression, Saif. Do not type in the chat box, I will not be able to see the chat box. Guys, am I audible?
Yes, ma'am.
Just get me an expression. Oh, what's the big deal in just getting an example expression?
90
One
minus,
second. 9? 19 minus?
minus
1?
86.
Get me some long expression.
Ma'am, I said 90. 90.
90, okay, 90.
Minus 86 into 4 plus 40 into 55.
65?
Yeah.
Okay. Any brackets here?
Nothing.
You don't have any brackets. Let's assume that the expression has got a sub-expression inside it already. Right? We are not going to, it is not we parenthesizing the expression. The expression itself is having a bracket over there. So if this is the input expression, now let's try to convert this infix expression into postfix. So how can we do that? How can we do this? Scan and try to find out the operators. This plus is already within is given within brackets, so we are not going to do anything with this. The other operators what we have here are, so we take this bracket as an operator, right? So it is already there. This operator has the highest precedence, so we are not going to disturb that. The other operands, like other operators we have are minus, star and star. So reading from left to right, I can just parenthesize this part of the expression first. And again, the next bracket will be for this part of the expression. And then here. Now try to convert. So when I try to convert, what will happen? The innermost expression should be taken first so that you'll not go wrong. Right? And this star will get mapped to this. And what is next? Next expression is this star. So here, and this minus will go here. So this needs practice. You have to work a lot, only then you'll be able to do it in a faster manner, right? So it is just identifying the nearest or the closest closing bracket to the operator. I try to find the immediate closing bracket for all the operators. For this, the immediate closing bracket is this, and for this minus, so this is the expression that is, say, 90 minus complete sub expression, say y, right? So it should be assumed like this. So then this bracket which is coming after y will be the closest for this minus. So that is why it has been mapped here. Hope you understand this, right? So now rewriting the expression, what will be the answer? Rewriting the expression, postfix form. I just drop all the opening bracket, take 90, then read minus going somewhere else. It is not going to appear after 90. And next comes all other opening brackets here. So simply drop. Next is 86. And next is again an operator which is going somewhere else. So I'm not going to bother now. Next plus, 4. And next is plus is also taking some other position. So 40 next. And this closing bracket is mapped with plus, so I take plus, and this closing bracket takes star, and star is going somewhere else. Then comes 65. Next is again minus, so I stop. Just a moment. And now. இங்க வச்சுங்க ஒரு
வச்சிரவா
வச்சுங்க அப்படியே எல்லாம்
அங்கே ஆபத்தா
கையில் பூசிட்டு வந்தேன் நீங்கள் கதவு சாத்திங்க மிளகா So I hope this is clear. Guys, am I audible?
Yes, ma'am.
Okay. So here what happened is like finally we had this closing bracket mapped with this minus, so we just took minus here, and that marks the end of the expression, so we just stop. Okay. And now let's see how this is going to be evaluated. So this postfix expression, as I said, normally the evaluation will happen from the left hand side, as in the case of infix expression. The system is going to scan the expression, and when it finds an operator here, it will stop and apply the operator with the preceding two operands, because this is a binary operator, right? So 4 plus 40 will be evaluated. அது இருக்குது அது ஸ்விக்கியில் வந்துருக்கு 4 plus 40 will be evaluated and you'll get the answer here. So you have 44 and all other values will remain the same, and this has been consumed, so we are not going to have this plus anymore there, right? So we have the star 65 and minus. Now start reading from this point onwards. You need not scan again from the beginning. Start reading from this point onwards. So it is again an operator, so stop. and apply this operator. Apply this operator on what? These two, because this is a binary operator. So 86 into 44. What is the answer? 86 into 44. Sorry. Answer number, somebody just type, check in the calculator. You're going to have 90. What is 86 into 44? Somebody out there in the class? எல்லாரும் சிஸ்டமில் லேப்டாப்பில் தான் வச்சுருக்கீங்க. நடுவில் டக்குன்னு ஒரு கால்குலேட்டர் போட்டு சொல்ல முடியாதா? நானே போட்டுறேன். Guys, is the class very boring? Why there is no response? I thought of completing at least one algorithm today. Am I audible first of all?
Yes, ma'am.
And then why there is no response? If you don't feel like attending class, you please let me know, I'll stop. No answer for any question. So let's take something as x here, some result here, right? And again start reading. So you're going to read from, so resultant value, let me write in.
Excuse me, ma'am.
Hmm?
Ma'am, there's an answer in the chat box. I'm just going to read it. Page 378.
See, I am telling you continuously that I will not be able to see the chat box. Please unmute yourself and give the answer, because I am just sharing the entire screen. If I'm going to share the window, then I will not be able to have enough space to write and show you. So I will not be able to see the chat box. Please understand, do not put anything in the chat box. I will not be able to see. If something is posted as a question to you, try to answer by unmuting yourself.
Yes, ma'am, I understand, ma'am. I'm just stating what he has written.
Huh?
Yes, ma'am, I understand, ma'am. I'm just stating what he has written. He has given the answer as 374.
3?
784.
Okay, some number here, 378.
84.
84. Okay.
Yes, ma'am.
So here this is the answer for this after applying the star. So we start reading from 65. So 65 is an operand, so we don't do anything. So wait, let me change the color. So 65, we are not going to do anything, and we just start scanning from the next point onwards. So next character is minus. So minus is an operator. So when we read an operator, when the system reads an operator, it is going to apply the operator. So this minus is going to be applied on this. I think we are wrong somewhere. Did I leave any? One star has been left here. Look. Plus star, then 65 star, and then minus. I made mistake here. Can you see it here? See, after the 65, this closing bracket should be mapped with star, and then we should have minus. So I made mistake, that's why I am getting it wrong. So it is star, which is going to be read next, right? So you're going to apply the star on these two operands. Sorry, 84 into 65. So supposing you're going to get some y as the result, right? So here you have 90 undisturbed, and this answer you get some y, and then you have minus, right? And now start reading from here. It is the next operator that we read from the expression, and so we apply this operator. So it is 90 minus y, which is the answer, right? So just in single scan, what you have to understand, what I try to put in your head is to understand that in one single scan, the entire expression is evaluated. Whereas if you give the expression like this, if you give the expression as say minus 86 into 4 plus 40, which is in infix form, right, star 65, then the system has to scan and find out the first sub expression. This is scan 1, right? and it takes the result. It is 6 stars. You say you get some result x into 65. Again, it has to scan the complete expression in order to find the priority of the remaining operators, and it understands that this has the higher priority of all existing operators. So now this is scan 2, right, and it gets the result as y. So 90 minus y into 65. Again, it has to scan and find out that this is the next operator to be applied, and you get some result. 90 minus y into 65 says z, right? So this is scan 3, and again it has to scan. So when it scans, it will get only this minus and this delimiter. So it understands that this is the only operator that is now remaining to be applied on the operand. So it will just, again, anyway, it needs to scan, and now it gets the result. So if you just look into the very simplest expression, it does 4 scannings. 4 times it has to scan the complete expression from left to right. Right? So which is going to be a tedious job, a time consuming job, when the expressions are complex. Right? When the expressions overrides the operator's precedences, then again it is going to be very, very complex. So to avoid these things, what the system or the compiler does in the background is, it will just try to find out all the expressions and convert all the infix expression into postfix or prefix, right? So that in one single scan, the evaluation of the expression could be done. The time that is involved in evaluating expression is going to be minimized when the expression is going to be in prefix or postfix form. Why? Because the prefix and postfix is not going to look for the priority. So the prefix or postfix expression are going to be generated considering the priority of the operators and the parenthesis that overrides the other operators' priority. Hope this is clear. You have to understand why this is really needed. So understanding how it is going to be done, it's secondary. Why, what is the reasons we go for which we convert the expression into postfix or prefix, that should be known very clearly. So that will be the question in the interview when you go for placements. What will happen if the expression is not converted into postfix or prefix, and if you're giving the infix expression, what is the time complexity of evaluating an infix expression compared with the time complexity of evaluating an expression in postfix or prefix form? It is obviously going to be lesser, right? So these are things that you have to be clear with, and then the next step is to understand how the infix expression is going to be converted into, or what is the method used to convert an infix expression into postfix. So now how are we going to implement this? So the next step is to, being a computer science student, I should know how this infix expression is going to get converted into postfix or prefix in the computing system. So manually I told you how it is going to get converted. So again, in the manual method, you're going to scan the entire expression for many number of times in order to find the priorities. So implementing this, so parenthesizing the expression completely, is again a very tedious process. Doing it manually, maybe it seems to be easier, but when you try to implement this, then you're not reducing the time at all. It's going to take the same time. You're going to scan the expression for many number of times to identify the priorities of the operators and then parenthesize it, right? And then how are we going to do this in a time effective manner? That is what is the problem with us in front of us now. So we're going to make use of stacks to convert the infix expression to postfix without parenthesizing it. Parenthesizing it is going to be easier when it is done manually, but when we try to parenthesize the expression using a computer program, when we try to write a program to parenthesize the expression, it's going to be very, very time consuming process. So instead we can just make the system to work with infix expression itself, right? So it doesn't save any time for us. So we try to make it a stack and try to convert the infix expression into postfix.